In this video, we'll be going over 5.5a CAD model features, part 1. And the purpose of this is to introduce you to some new tools in Autodesk Inventor to make you more efficient when you are designing your CAD models. And the first tool that we're going to be jumping into is called the revolve. Some of the sketching techniques that we're going to be using, construction lines and basic geometric constraints. Just so you know, they're using construction lines, but I'm going to be using a center line instead. Some of the feature tools that we'll be using a revolve, a fillet, work axis, and a work plane. So what do they want you to make with the revolve tool? They want you to make this rubber handle sleeve for a button maker. And if you notice, they give you the isometric along with this detailed 3D model that has been sliced in half. And we call that a full section view. And normally they'll do a full section view like that so you can see the interior detail. This slanted pattern is called hatch, and that is where the blade would touch the material as it cuts through it, if you can imagine like a saw going right through the middle of that. And again, it's to show interior detail so that way you can see everything that's going on. Like for example, you can't see the little hole in the bottom when you look at the 3D solid model here. But then when they do the full section, you can see that little 0.1875 diameter hole in the bottom. Some other things to make note of, you got some fillets going on the edges. So there's one, it's on both edges, and that has a radius of 0.25. Notice OD. OD stands for outside diameter. So the outside diameter of this is 1.375. They give you an overall width. They also indicate the thickness here, so that distance. And then they also indicate some thickness here. Now we're going to be using this measurement to figure out the inside diameter, so this inside hole, using this dimension and this dimension. Just some basic math to figure that out. So down here below, they actually start to tell you how to do this. So how does the revolve tool work? Well, you have to create a half section. So if you take a look at this right here, look at this L shape, this and this, right? And then this center line. So down here, that's the sketch they want you to make in the front view. They want you to make this L shape, and instead of a construction line, we're going to use a center line here. And then how does the revolve tool work? Well, once you draw that sketch and it's fully constrained, you can then revolve it around that center axis to create that cylindrical shape. So they give you some basic numbers in the beginning. They tell you the 0.156 and the 4.469, so they're giving you two width dimensions, but then you're missing some diameter dimensions that they want you to figure out, like this one, and then this one pertains to the inside diameter. So I'm going to help you do that, and the first thing we'll need to do is create a new folder for this unit. So what I'd like you to do, and I'm giving you some of these directions in OneNote if you have me in class, in your Inventor folder that we have, I'd like you to make a new folder called 5.5 CAD Model Features Part 1. So please go make that folder right now. And then we will save each one of the models that you create inside of that folder. And then we'll also be doing some screen clipping of your models in here so you can get a grade for your work. Alright, so let's go ahead in Inventor. Let's start a new part file. English template, standard inch IPT. And again, we are going to start in the front view with this. So I'm going to go start 2D sketch on my XY plane. And the first thing I want to do is draw the center line. And if you remember, the center line is going right through the middle of the object. We're going to create a center axis for us to revolve around later. Now when I draw that line, I want it to be the exact overall width of the part. So 4.469. So I'm going to draw a line from my 0, 0, going straight across the x-axis. Notice the horizontal constraint, and again, that is going to be 4.469, and I'm going to hit enter, hit escape, pan over. And the only problem is that this is a solid object line, but we want it to be a center line. So I'm going to click on it. And then up here in the Format panel, I can click on the center line option. And you'll notice it is now in the center line layer. So I can hit Escape to get out of that. And then now let's go ahead and start completing our sketch. So what I'm going to do is just do a rough sketch. I'm not worried about any numbers right now. The only thing that I'm going to be paying attention to is that I'm staying parallel and perpendicular to ensure that I'm drawing perfectly straight lines, but I'm not worried about the numbers right now. We're just going to do a rough sketch. So I'm going to go line, and then I'm going to go ahead and now with this first line, you want to make sure you're snapping to the y-axis and that you're starting it below the center line. So I'm going to click over here, and your mouse will automatically snap to it if you hover over it. So left click anywhere, doesn't matter, and then just go straight across. Notice the horizontal constraint. Again, I'm not worrying about numbers, and then I'm going to go down, and then I'm going to go over. Now with this one, yes, I want to be perpendicular, but I also want to snap to the end point of that 4.469. I shouldn't say snap to, I want to reference it. So notice once I get really close, you'll see that dotted vertical line coming down from the end of the 4.469. Snap to that and left click. Then I'm going to go straight down, staying perpendicular, going back over. Now with this one, I want to stay perpendicular and I want to snap to my y-axis. So I'm going to click there. Then I'm just going to simply go up and close it back off with where I started. Then I'm going to hit Escape to get out of the line tool. So I have my basic sketch, but now we need to constrain that. If you notice down on the bottom, it's saying we need 6 dimensions to get this thing fully constrained. So I'm going to start with what they gave me. Let's go with the overall, the 4.469. So let's dimension this line. So dimension here, 4.469. Yep, that's good. Hit enter. And then I believe this one was 0.156 if I'm not mistaken. Yep. So I'm going to click on this one and I'm going to add in that dimension, 0.156, enter. There we go. That's looking good. So now we need to figure out the ones that we're missing. So these are our diameters, this one and this one. So let's do these two first. Let's talk about what this is though and where this dimension is being pulled from. This actually is a radius dimension here. And let's go take a look at the 3D model so you can see where that's coming from. It's coming from right there. So again, that distance right here is coming from right there. And let's zoom in on that so you can see it a little bit better here. So the distance from the middle of the circle to right there is the radius of that circle. And that's what they were asking for in that drawing below that they left blank on you. But we're going to be using the diameter. So it's 0.1875, so that's the distance from here all the way to here, right? And we have that center line going through the middle. Since we use the center line, we're going to be able to use the diameter, and you'll see why in a minute. So the number we want to remember is 0.1875. So I'm going to go dimension, and again, we're going from the center line to this edge right here. Notice that it automatically did diameter. It did a diameter dimension because I added that as a center line and not a construction line like they did. So I can type in 0.1875 for that measurement. So that's how big that hole is that they're talking about right here, right? So that's 0.1875. The next one we're going to do is this one. So that's from the center line all the way to the outer edge of the circle, which is from here to here, which is referencing the outside diameter, right? Because from there to there would be the radius, but we're going to be using diameter, and the outside diameter of that entire cylinder is 1.375. So for this dimension, I'm going to go from the center line to my outer edge. Whoops, there we go. Yep, I'll put that over here. And we said that that was 1.375. Enter. All right, we're starting to get some purple lines, looking good. I'm going to pull this out a little bit so those aren't running into each other. All right, I believe we need 2 more. Yes, if you're taking a look down here, we need 2 more constraints to fully constrain this thing. So the other one that we need is an inside diameter. And actually, before I do this, I totally forgot to tell you, whenever we start a sketch, we should have saved right away. So as soon as we're done with this sketch, if you didn't save already, we need to save this, and we'll call it, we'll call it the rubber handle sleeve. So we'll be saving it there. So I totally forgot to do that, slipped my mind. All right, sorry, a little off topic there, but it is important to save. So where was I? We're trying to figure out the inside diameter. So I know they give you this, which is, that's actually just 0.25. But we're going to, instead of doing this dimension, we're going to do a dimension from the center line to the inside edge, which would be the inside diameter. So how do we figure that out? Well, you're going to take this minus 2 times 0.25 because you have it here and you have it here. We're trying to figure out the diameter or the inside diameter. So 1.375 minus 0.5 leaves you with a diameter of 0.875. So now I can go add in that dimension. So dimension from here to here, and like we said, that'll be 0.875. Now we're almost there. We need one more dimension. Notice it's all 3 of these vertical lines. It's because I just started this initial point only on the y-axis, so I could still move it left or right on the x-axis. And if you right-click, let me hit escape to get out of the dimension tool. If you right-click and turn on show all degrees of freedom, you can see that each one of those green lines can move left to right on the x-axis, so they are not constrained yet. If we constrain this bottom one to the origin using a coincident constraint, it'll lock down all 3. So I'm going to right click and turn off or hide those degrees of freedom. And then what I'm going to do is use a coincident constraint, click on this line, and then click on my origin 0, 0. Notice now that my sketch is fully constrained, we're locked down, so I can finish. And now let's go back to what I was talking about. Let's make sure we do a save here. Totally forgot about that. So do a file, save as, and we are going to call this rubber handle sleeve. Whoops. And if you want to put a dash, revolve, so you can remember what tool you learned. So we'll name the part and then we'll put the tool that we were focusing on in Inventor. And then what you're going to want to do is navigate to wherever you're saving into that new folder that we just made. Remember, we called it the 5.5a CAD models features part 1. Just save the part in that folder and then you're good. Alright, so go ahead and do that save, please. So now that we got the sketch all done, we're ready to revolve. And the revolve tools right here, R on the keyboard is the keyboard shortcut. And you'll notice you're taking a 2D sketch, rotating it around a center axis to create a 3D model. So that's what we're about to do. As soon as I clicked on the revolve, it automatically recognized the center line. It recognized my profile, which is that L shape, and it's giving me a preview right now of that sketch being revolved around this center line, and they're automatically doing a full revolve. Now, just so you are aware in the future, if you didn't want to do a full 360 degrees, you could change the degrees to whatever you want. You don't have to do a full revolve. So that might be something to think about that could help you in the near future, maybe with a future project or model that you're working on. But for this sake, or for this part, we're going to do a full revolve. And then I'm going to say OK. So if I shift and hold the mouse wheel, I can orbit around. We're almost there with the modeling. We still have the fillets to add. So if you remember, there's a rounded edge here and then another rounded edge here, and they indicate that with an R.25, and then remember TYP stands for typical. So that means that it's on this edge and on this edge. So let's go ahead and add that in. So the fillet tool is up here in the modify panel. F on the keyboard is the keyboard shortcut. And we need to change and adjust this radius to, they said 0.25, so I'm going to get rid of the 1 there. And then all you have to do is click on the edges. So we're going to click on this outer edge here, and then I'm going to zoom out and orbit around a little bit, and I'm going to get this outer edge here. So there's two of them. So I just filleted both ends, and then you have to click OK. So now we have our rubber handle sleeve, and we're looking pretty good. Let's add in some materials. So remember, it's rubber, so in this first drop down I'm going to go ahead and scroll down and find rubber. And the black is pretty dark, and you start to lose some of the it's a little bit harder to visualize with such a dark material on there. So there is some other options for rubber. They have a blue, but the blue for me, with the way my background is in Inventor, it kind of loses a little bit. So I'm going to go with this green, this rubber green, kind of have a little bit contrast there between the colors, a little bit easier to see. All right, and then hit the save button, or actually, you know what, before you hit the save button, let's go update our eye properties. So File, Eye Properties. So since we added the materials, I want this thing to calculate the mass, area, and volume based on the density of rubber. So if under Physical, I can click on Update, and now it has just calculated all that information for me. I can hit Close, and I'm going to hit Save. And then go ahead and save that. Just keep saving over the same file. And the last thing that we have to do before we're done with this is add in 3D annotation. So a little bit different than what we've done before. Normally I would have you do a drawing with the multi-view front, top, right side and the isometric. We're going to change it up a little bit and just do some annotations right in here in the model. And then that is, we'll talk about how you'll turn that in after we're done. So let's go ahead and add those in. And there are 3 annotations that we're going to add in. So I'm going to click on the Annotate ribbon up here, and then I'm going to go to Dimension. So what we're going to actually be doing is adding in dimensions right onto the 3D model. The first one I'm going to add in is the overall length. Remember, that was the 4.469. So to do that, I'm going to click on just this little edge of this inside diameter. Right? So I'm going to click on that. And then I'm going to orbit around, and I'm going to click on this edge of this circle right here. Okay, so we're almost there. I'm going to hit the Home button, and then I'm going to bring this down. I'm going to zoom and pan out. I'm going to bring this down below, not too far, just a little bit under the model. And then I'm going to left click. The only problem is that the precision is wrong. We need to go, what, 1 more decimal place, right? Yeah. So to do that, you can click on this little button to edit the dimension. And then under Precision and Tolerance here, I can change the units, and I can change the precision of the units, and you can see it right over here. I'm now going to that thousandth decimal place. I can click OK, click the check mark. That dimension is good. All right, let's do the next one. Let's do the inside diameter. So the inside diameter, we're going to click on Dimension. And I'm going to click on just this edge of the circle. And I'm going to put this one right here. And then, again, the precision is not correct. So I'm going to go to Edit Dimension, Precision and Tolerance, adjust that to the thousandth. And I want to go back to text because I'm going to add in all caps, ID. And again, that stands for inside diameter. And I'm going to click OK. Click the check mark. That one's good. While we're here, let's go ahead and do the outside diameter. So Dimension, I'm going to have you click on just this edge right there. Now, I don't like the way that's facing, so if you hit Tab on the keyboard, it changes the orientation of that 3D annotation. So Tab on the keyboard will rotate it and change it. So I like that. That looks good. Again, I want to adjust the precision, and I want to add OD to it. So I'm going to edit. While I'm right here, I'm just going to type in OD, go to precision, go to the thousandth decimal place, say OK. Click the check mark. While we're over here in this portion of the model, let's go ahead and dimension. So click on Dimension, and let's do this, the fillet. Now I'm going to hit Tab. And that looks pretty good right there. I can live with that. I'm going to left click that, and then I'm going to edit, and then remember they had TYP after it, so typical. TYP period. So space, TYP, check mark. That's good. Next thing I'm going to do, let's orbit around and get the hole on the back right there. So I'm going to dimension, click on the edge of the hole there, and then I'm going to hit the home button, right? And then now I want to change the orientation, so I'm going to hit tab. There, that looks good, but the precision is wrong. So I'm going to click that, edit. And while I'm here, actually, let's type in the word, or THRU. That stands for through, meaning that hole goes all the way through. And I'm going to change the precision to the thousandth decimal place. And then say OK. Check mark. That's good. And actually, I lied. That should go, we need to go one more decimal place. Double click back on that dimension. Click edit. Precision and tolerance. We got to go one more decimal place. There we go. And then we got two more things we got to do. We're going to put a note on the material, and then we're also going to put the author information. So to do those, I'm going to do a leader text where we can type in whatever text we want. And I'm going to I'm going to hover over this outer surface here, and I'm going to get close to this edge and kind of click right there. There we go. And right there, I'm going to type in, so if you left click again, you can type in material, rubber. Say OK, and then I'm going to do one more of those. So I'm going to click on leader text, but this time I'm going to scoot down a little bit, try and click on this edge, bring that out, left click again, and you're going to type in created by, enter, and then type in your full name, and then say OK. Finally, do another save. And we are all done with this. So what you need to do is just save it. And then I would like you to Windows Shift S, and actually hold on, before you screen clip, scoot the model over here because I would like you to include your browser. I want to see what you did and I want to see what you made. Also expand this so I could see, actually you don't have to expand that, that's fine. But scoot the model over, so pan it over, and then do a Windows Shift S to screen clip. And I just want this right there. That's what I would like you to screen clip and paste into your OneNote binder. You'll see it in there. It says, screen clip the rubber sleeve here. And then that'll be it for this portion of 5.5a.